So looking at the back of the particle motion worksheet, record is the note to self to do what I'm doing, record it. The figure above shows the velocity. So this is another one of those graphs where make sure you understand what you're looking at. That's the velocity of a body moving along a coordinate line. When does the body reverse direction? Okay, so forget about the graph for a minute. What would you say about velocity? Or what would you need to know about velocity to say it reverses direction?
Negative? Oh, it changes signs.
It changes signs. There we go. V changes signs. So it changes from negative to positive or positive to negative, because either one of those would be a change in direction. So V changes signs at, and by the way, that's our justification. I always like to do the justification first because it clarifies what I'm looking for. V changes signs at, so give me a time where V changes signs. 2, 7. 0 and 10 you can't really say because you don't know what's happening on either side of, or on the other side of 0 or on the other side of 10. So maybe, but we're not even looking past 0 or 10. So 2 and 7 would be the only places. When is the body moving to the right? So what would I be looking for if I'm moving to the right? What's positive? V. Yeah, so you just got to be clear on what you're saying. So V is greater than 0. So where's V greater than 0? 0 to 2. And 7 to 10. Good, we're getting good at reading graphs. Moving to the left, that would be V less than 0. Where does that happen? 2 to 7. When approximately is the body moving at a constant speed? 3 to 6. The velocity isn't changing from 3 to 6. Oh, yep. Okay, when is the body's acceleration? Positive. Negative 0. I think you're right, but what is acceleration? Like, how do I know what to look for?
Where everything increases.
Because what is, I mean, you're right to say increasing. It's the slope. That's really good. So I was going to say dv dt, but that's the slope of v. So the slope of v is positive from where to where? Good. 0 to 1 and 6 to 8. Good. And the slope of velocity is negative on 1 to 3 and 8 to 10. 0. So the slope of velocity is 0 from 3 to 6. So not a hard graph to read as long as you understand what you're looking at and what they're asking for. When does it move at its greatest speed? I don't know that we've actually said this yet, but speed is the absolute value of velocity. So speed is just how fast you're going, without regard to forward or backwards. You say that in physics, usually say speed is the magnitude of the velocity. So it's velocity without the direction on it. It's kind of the same thing here. So when is it moving at its greatest speed? Oh, there's lots of places. Well, what is its greatest speed? Maybe that would be the first question. What's its greatest speed? 3. So its greatest speed is 3. That happens at t equals 1. And then this range from 3 to 6. And then t equals 8. So like for an instant at 1 second and at 8 seconds, but then a constant 3 meters per second, or feet per second, meters per second, from 3 to 6. Graph the body's speed for 0 to 10. So I'm going to graph it on the same graph. I'm going to use green for speed here. So if speed is the absolute value of velocity, then what am I going to do to make a graph of speed? Okay, it needs to not go negative. So I like that. So what do I do with this negative stuff up down here? Great, yeah, flip it over and make it go to the top. So we could pick a few points and reflect them over, like that point at 6. And so there's velocity. Well, I guess I should do the rest of it as well. When v is positive, then v and speed are the same thing. So be careful. Speed's easy to do as long as you understand, what you're talking about. And then lastly, graph the acceleration where it is defined. So I'm going to pick a different color, and on the same graph acceleration. And we said already that acceleration is dv dt, which is the slope of v. So let's see. From 0 to 1, what's the slope of that line? 3. So my acceleration is 3. From 1 to 3, what's the slope of that line? Negative 3. So from 1 to 3, there's my slope. This looks a little bit funny, I'll grant you that, doing them on the same graph. From 3 to 6, what's the slope of that line? 0. So from 3 to 6, acceleration is 0. From 6 to 8, acceleration is 3. And then from 8 to 10, not as easy on that one. Negative, yes. Negative rise over run, 3 over 2. So negative 1.5. So there's our acceleration. I guess officially those should be open circles at the end, but that's pretty minor on all of those acceleration graphs, because the slope of a cusp isn't defined, so there's not an acceleration at all those cuspy points. Alright, so that finishes out the worksheet, finishes out the new stuff for this unit. Again, today I'll get you a second worksheet that you can work on in class today. We'll work on it tomorrow and review tomorrow, and then we'll test on Friday.